Hello students. In the last video, we showed you how to determine if a particular expression, such as this one, fit the pattern of a perfect square, a squared plus or minus 2ab plus b squared. And if it did, we could then write it in the form a plus b all squared or a minus b all squared. So we're going to continue looking at questions like that, and the only difference is these expressions are slightly more complicated than the ones that we looked at in the last video. But the method's the same, so let's get started. So, is this a perfect square? Does it fit the pattern of a squared minus 2ab plus b squared? Well, if it does, 25y squared is a squared, so a is going to be 5y. B squared is 9, so b is going to be 3, and the middle term, 2ab, is 2 times 5y times 3. Well, 2 times 3 is 6, 6 times 5 is 30, so 2ab is 30y, and it fits the pattern. And that means, therefore, that can be written as a minus b all squared. Now you could, of course, check that by expanding that out, and you have to get back to that expression just there. Okay, I'll try this one just here. Well, if that's equal to a squared, then a has to be 2x. If that's equal to b squared, b has to be 3. And then 2ab has to be 2 times 2x times 3. Well, 2 times 3 is 6, times 2 is 12x. So the middle term has to be 12x, and it's not. So that one's not a perfect square, and therefore we can't factorize using this particular pattern. Again, it may be factorizable. It can be factored using another rule, but not by using this rule. Okay, I'd like you to have a go, please, at these two questions just here. Okay, let's see how you went. Okay, if this is a perfect square, that's a squared. So a squared is 9x squared, so a is 3x. B squared is 4, so b is 2. And 2ab, which is the middle term, is 2 times 3x times 2. 2 times 2 is 4, times 3 is 12. So it has to fit the pattern of 12x, has to equal 12x, which it does. So therefore, this is a perfect square, and that just equals a, which is 3x, plus b, which is 2, all squared. And once again, you can check that by expanding that out to see if you get back to that. Okay, how'd you go on the next one? Well, if that equals a squared, a must be 2y, b must be 5, since 5 squared is 25, and 2ab is 2 times 2y times 5. Well, 2 times 2 is 4, times 5 is 20y, but we have 18y. So that one cannot be factorized using perfect squares. Well, we have one short video to finish off, and you'll have learnt all you need to know in year 9 at least about expanding a binomial times a binomial.